All right, here we have the notes for section 1.1, modeling and equation solving. So we got a definition down there first. A mathematical model is a model or mathematical structure that approximates phenomena for the purpose of studying or predicting their behavior. So typically the easiest model to work with is a numerical model, which you just have essentially a table of data, which if we turn over to example 1, on the next page, there we go. So example 1, the table shows the growth of the federal minimum hourly wage from 1955 to 2015. The table shows the minimum hourly wage adjusted to the purchasing power in 2015 dollars. So you got the lovely table, so starting at 1955 all the way down to 2015. So there's our questions. In what 5-year period did the actual minimum hourly wage increase the most? So you're looking in the middle column there for the greatest increase. So that's 25 cents, 25 cents, 35 cents, 50 cents. That's $1. That's 25 cents from there to there. So it's probably that one, the dollar. Is there anything more than that? There's 90 cents. Nope, down here. So down here at the bottom, that is $2.10. So from 2005 to 2010. Greatest increase from 515 to 725. And what year did the worker earning the minimum hourly wage enjoy the greatest purchasing power? So you're looking at the far right column. So that's that one right there. $9.74. So that would be in 1970. Okay, and then a worker earning minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970. So in 1970 it was $160, in 1980 it was $310. And yeah, there was a greater pressure to raise the minimum wage again. So the thing is, though, if you look at their purchasing power in 1970, that was $9.74 worth of goods, and in 1980, that was $8.89 worth of goods. So the purchasing power had decreased. All right, so on to example 2. So this table shows the fluctuation in the number of commissioned officers on active duty over selected years from 65 to 2015. It's the proportion of female officers increasing over time. So you're looking at what the percentage of the female officers. So here you have 4 out of the 102, 6 out of the 144, 5 out of 90, 7 out of so on and so forth. Now you could actually calculate the actual percentage, divide 4 by 102, 6 by 144, but there's kind of an actually easier way to do it. If you look at this number is increasing down the female column, so more women are participating, and the total number is going down. So my numerator and my fraction is getting larger as my denominator is getting smaller, so it would be yes, it is increasing without having to do any math. All right, so an algebraic model is where you set up equations and use those to solve problems. So example 3 here, pizzeria sells a rectangular 18-inch by 24-inch pizza for the same price as this large, round, 24-inch diameter pizza. If both pizzas are the same thickness, which option gives the most pizza for the money? So I need to figure out the areas of the pizza. So for my rectangular pizza, area is length times width, or in this case, it's going to be 18 times 24, which is, according to my calculator, 432 square inches of pizza. For my circular pizza, area of a circle is pi r squared. So pi times 12 squared. No, that's 12 because the number it gives me is the diameter. I have to take half of it. So pi times 12 squared. This pizza has an area of 452.4 square inches. So the circular pizza gives you more pizza for your money if they cost the same amount. It is larger. Okay, so here you have a graphical model, visual representation, numerical model. So you're going to plot the points. So Galileo Galilei spent a good deal of time rolling balls down the inclined planes, carefully recording the distances they travel as a function of elapsed time. His experiments are commonly repeated in physics class today, so it is easy to produce a table, or a typical table of Galilean data. So what graphical model fits your data? Can you find an algebraic model that fits? So if you just thought about it, so you have 6, 7, 8 seconds, so it's, at 2 seconds it's a 3. So if you look at this pattern, This distance is getting more, so this graph is curving up. So the algebraic model would be the equation of the thing. So that's a curve, so the algebraic model is approximately something involving x squared. All right, so example 5. The table below shows the average life expectancy for persons born in United States each given year, census between 1950 and 2010. Model the trend graphically and use a graphical model to suggest an algebraic model. So once again, you would plot a t-table, plot the coordinates, and then figure out the equation of the line that passes through those points. So I'm not going to do plot the points, but if you wanted to find the algebraic model, you're actually going to use these guys and find the slope. So y2 minus y1 over x2 minus x1. So 78.7. Let's see here, minus 68.2. So on top, that's 10.5. On the bottom, that's 60. So 10.5 divided by 60 is 0.175. So that's my slope. The number here is the life expectancy when I started measuring it, so that is 68.2. So that would be a linear model that matches that data. Okay, on the other side, we have the zero factor property. So it says find all real numbers x for which 6x cubed minus 11x squared, or equals 11x squared plus 10x. So since I have multiple powers of x, my first step is I need to move all terms to one side of the equal sign. Then I'm going to start trying to factor. So these terms all have an x, so I can pull an x out. So that's 6x squared minus 11x minus 10 equals 0. So what the zero factor property states, so it's down here, a product of real numbers is 0 if and only if one of the factors in the product is 0. So this is a product. So in order for this equation to equal 0, either this has to equal 0 or that has to equal 0. So this one is relatively straightforward to solve, because in order to make x equal to 0, it just has to be 0. This one, though, is a quadratic, so I need to do the quadratic formula for it. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's see here, negative 11 squared minus 4 times a times c. Oh. There you go. So this is 11 plus or minus the square root of 361 over 12. 361, I believe, is a perfect square. It's 19. So this is 11 plus or minus 19 over 12. So 11 plus 19 is 30 over 12. So x is 5 halves. And then do the minus, 11 minus 19. So negative 8 over 12 is negative 2/3. So those are my solutions, all three of them. So you can't forget that one, 0, that, and that. All right, so down here, 7, similar setup, multiple powers, so everything needs to move to the left. Set equals 0. That once again is a quadratic, so negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's 16 plus 40 underneath. So that's 16, that's going to come out to be 40, so that's negative 4 plus or minus the square root of 56 over 2. 56 is not a perfect square, so I'm going to need to factor tree it. So 56 is 2 and 28, which is 2 and 14, which is 2 and 7. So there's a pair of 2's. The 14 goes back together, so negative 4 plus or minus, let me check my work before, yeah, 2 square root 14 over 2. And that can be simplified one more thing because these numbers are all even, so negative 2 plus or minus the square root of 14. Negative 4 divided by 2 is negative 2. 2 divided by 2 is 1, and you can't factor out of the root 14. So down here at the bottom, we just have some definitions. So it just says that these things are all equivalent, regardless of what the question asks you. A root or a solution, the 0 or the x-intercept, like they all mean the same thing, whereas the graph have a y value of 0. Okay, last side here. Example 8. The engineers and auto manufacturer pay students 8 cents per mile plus $25 per day to road test the new vehicles. How much did the auto manufacturer pay Sally to drive 440 miles in one day? So I'm going to use this information to create an equation. So y equals, so that's the rate they get paid. So that's my slope plus $25, because no matter what, you make $25. So Sally drove 440 miles. So that would be her equation. X would be 440. So 0.08 times 440 plus 25. Sally made $60.20 that day to drive 440 miles. John here, we're going to work backwards. We know how much he earned. We know how far he drove. So we actually know John's y value. So 93 equals 0.08x plus 25. So subtract the 25 across. Gives you 68 equals 0.08x. And divide by 0.08. So John had to drive 850 miles in one day to make that money. All right, so 9, just talking about the graph. Look at that graph. So let me get my calculator here. Menu graph 3 minus the 1 over the square root of x squared minus 1. Draw. Switch. So looks like that. So it says, are there any x-intercepts? So according to this graph, if you look, there are, that's my cursor, there are no x-intercepts. The graph looks like it's going to hit at 1 and -1, but it actually does not. If you notice, there's no values there. If you're looking at the x down at the bottom, -1, I have an error, and then it starts to generate the values again. So this would be no, even though it may look like it with the graph. If you're zoomed too far in or out, if I zoom out again, we'll zoom out from the origin, it makes the graph look like it does touch at 0. So you have to be careful. So this one says solve graphically. So we'll put my equation in here. So x cubed minus 1.1 x squared minus 65.4 x plus 229.5. Draw. So it looks like that. And then so if you look, this looks like there's one solution, but this is an x cubed equation. There should be 3. So I need to zoom out. So there's the other one, but I'm still missing one solution. The trick is, if you actually look right here, see how many times I have to go in. We'll go in one more. So if you look, there's actually 2 zeros right there. One at 5 and one at slightly more than 5. So some calculators, though, do have a way to solve it. So I'm going to set my review window back to the standard one. Whoops. Or auto. That's no good. There we go. Okay. So there's a root at -9. There's a root at 5 and at 5.1. So x equals -9, x equals 5, x equals 5.1. So you have to be careful with your view window, how your calculator displays the information. That is the end of that section.